Students, we have completed the chapter of thermal expansion of solids in your theory classes, and we have discussed the numericals based on your coefficient of linear expansion of solids, isn't it? Now, students, we will discuss the numericals of coefficient of superficial expansion. Okay, I will just let you remind of the coefficient of superficial expansion once again. Okay. Okay, so let's start. If S1 be the initial surface area of a solid at T1 degree C, that means S1 is the surface area, initial surface area of the solid, and it is kept at the temperature of T1 degree C. Okay, and S2 be the surface area at T2 degree C. S2 be at T2 degree C. Okay, yes, so you have to assume that your T2 is greater than T1 degree C. This you have to assume. Okay, so how to write the coefficient of superficial expansion? We generally write it as beta. Beta equals to what? S2 minus S1 by S1, and one big division sign, or divided by T2 minus T1, isn't it? Yes. So this is our coefficient of superficial expansion. You can also just write it in this way: S2 minus S1 by S1 into T2 minus T1. Okay, and yes, so this is our final expression for this beta. Now, as I told you all, that it's better to memorize the value of your S2. Okay, S2 will be what? You just arrange it mathematically, so S2 is divide of it's without any other terms. So S2 will be equal to your S1 into, or you can use one second bracket also here. One second bracket, 1 plus beta T2 minus T1. Okay, and you just close the second bracket. Okay, it's better to memorize this value. And in today's class, we will be discussing the numericals based upon this only. So let's move ahead with the sum. This will be your sum number 5, I think. Okay, you can just check it out from the PDF provided. What is the question? I will dictate. The base of an iron saucepan has a diameter of 0.20 meters at 15 degrees C. Okay. What will be the increase in area of the base of the saucepan when it is filled with boiling water? Given the coefficient of linear expansion of iron is equal to 12 into 10 to the power minus 6 per degree C. Okay. So what is the question given? That is the base of an iron saucepan given, and its diameter also given, and its initial temperature is also given. So you have to find out what increase you will observe. Just keep this in your mind, the increase in the area of the base of the saucepan. This you have to find out when it is filled with boiling water. Clear? What is the data provided? Your coefficient of linear expansion of ion, give it the value. So let us start the sum. So before starting, students, you just check out from the first statement. Your diameter is given. So if diameter is given, you can easily find out the value of radius. So the radius of the base will be what? Divide by 2. So 0.20 divided by 2 will be equal to 0.10 meters, isn't it? So if you just go through the expression for the coefficient of superficial expansion, you can write this expression once again. S2 minus S1 equals to S1, that means this, I'm just following this formula only. So S1 into beta into this T2 minus T1, isn't it? Okay. Why I am doing this? Because in the question you have been asked to find out the increase in the area of the base. So increase in the area means what? You have to find out this S2 minus S1. Okay, you don't find out the value of S2, find out the value of S2 minus S1. Clear? So now our maths part will start. S1's value is what? I'm just doing it here. S1 equals to, what is the formula for your area? Surface area of circle, it's pi r square. So pi into 0.10 square. Okay, so yes, so now find out the value of your beta. Beta will be what? It will be 2 alpha, isn't it? So I'm just writing here, beta equals to 2 into alpha, means alpha's value is given. You just see the relations of alpha and betas, we are using that only. So 2 into, what is the value of alpha? 12 into 10 to the power minus 6 per degree C, isn't it? Okay, and what is the value of T2 minus T1?